we have our high poly, and before we bake it we need to make the instances, and we're going to add a little extra geometry. So the next stage is to go in and make these 3 other pieces which will be instances of this main floor panel. So make sure it's an instance, and I'm just going to set this to 200 to 200. So the reason I'm using 200 is because I want to build a 4 meter texture in Unreal. That means it's 400 centimeters, and that means that each of these panels has to be plus and minus 200 centimeters, even though Max works in inches. So this one is minus 200, and this one again will be minus 200. Okay, so the other thing I'm going to do is that I have made some pipe and some hinge or kind of bracket pieces, and this is to again demonstrate and reinforce what happens when we make attachments and what happens when we modify this mesh. So this is our basic mesh. You can see it's in bold, which means that it's copied somewhere else, and we could also make it unique if we wanted to. So what I'm going to do is I'm just going to attach these pipes and brackets, and what you will see happen is that the other components, these 3 other instances, will of course inherit that modification. So because these brackets are located at the top, when these 2 meshes were attached together, the piece underneath also gained this extra piece of geometry, and therefore it appears at the bottom. What I can do is I can then put in my high poly plane, which is my projection plane. Now this projection plane is going to be above the floor, and the important thing is it must be above the floating geometry. So for instance, if we have a look at this bracket, you can see, in fact let's just select the element, you can see that it's actually floating above the surface. It will look as if it's inlaid when we render out the normal map, because you remember normal maps aren't based on height and they're not based on Z depth, they're based on the change in the direction of the surface. So this will look like it's inlaid into the surface, but I have to make sure that my projection plane is above it, and this will be the plane that I will use to bake down. Wherever you place the plane, that will define the elements of the geometry that will be captured in the baking process, and this is where all the texture boundaries will be. So let's bake out the normal map and the base color map. So I have my projection plane selected. I am going to go to rendering, and I'm going to go to render to texture, and this will open up my render to texture dialog. I'm writing it into my Unreal Projects production assets because I don't want it to go directly into the contents folder, not just yet anyway, and I'm probably going to be fiddling around with it in Photoshop or something. Enable the projection, and I am going to pick my subjects, and in this case I'm going to pick from the list, and it will be those 4 high poly floor planes. and I am going to make sure that my projection is reset. So in other words, this cage should be absolutely flat. As it's a plane, UV coordinates should be precise. So I will be using channel 1, and then I can add, in this case, I want to bake out the diffuse color map. I want to bake out the normal map. And later on I will probably be baking out maybe even a lighting map, and that might help me generate an AO map, which is an ambient occlusion map. But these two maps will be sufficient to get me started, and it will enable me to check if there's any problems. So what I'm going to do is I'm going to leave these set as default, which is what I tend to do, and then once I've checked them in Photoshop, I will then go in and I will name them appropriately. 256 will be reasonable for a test, so I will just go ahead and render. So here I am in Krita, and this is the 256, so it's a low res diffuse map that's come out. You can see that these corners are actually the center of the tile, and that's because of the placement of that projection plane, and if I move the projection plane around, I can control where these borders are. As this is tiling textures, it should be completely seamless, and if we switch to the wrap mode, we can see that we don't have any seams. So we know, because of the way I've rendered it, we know that the joint is right inside this diamond here. If we look at the normal map as well, we can see that this is the normal map. So this will be our diamond shape, and you can see at the moment it's right on the corner. And if I change our view to wraparound mode, we can see that these have baked out perfectly. There's no seams on the joints. We can see how these textures are going to look on a material actually in Engine. And because this material is using world space coordinates, that is coordinates that are locked into the world and not relative to the object, I can actually move the geometry around, and the texture will move relative to the geometry and stay static relative to the world. So we can see that the object moves, but the texture, or specifically the material, doesn't. And this means that if we alt drag, I can have two objects and they will connect together absolutely seamlessly. Now, when it comes to the texture, we can look at this bracket. We can see that it doesn't look like it's floating off the surface. So that's how the normal map gives this illusion of the change of the surface. Now, whilst as I'm looking at these pipeworks, it looks relatively good as I'm looking down on the surface, but we also need to be aware that from the player's perspective, we're going to get a very angular view, and therefore the illusion of depth will not hold up because there is no actual geometry, there's no actual depth in the physical artwork.